everyone. We are doing area of a sector and a circle today. Remember, if I go too fast, just pause the video. You want to make sure you have all of this written down, and if you need time to draw a diagram, go ahead and pause it. All right, so key concept, area of a circle. We've talked about this in our circle unit. We didn't really use it much. We used it a little bit. The area of a circle is pi times r squared. Remember, when we do area or we have a formula with pi, we don't actually multiply out the pi. We leave it as a symbol in our answer. Okay. And remember, r is our radius. Area of a sector is a portion of the total area. Now, if you guys remember, we did arc length, and arc length was a portion of the circumference. So I'm just writing this down as a reminder. So arc length, if you guys remember, the formula was the central angle over 360 times circumference. Because arc length was a portion of the circumference. Well, a sector, just so you guys know what a sector looks like, let's draw that. This is a sector. All this space right here that I shaded is a sector. So a sector is a portion of a circle. Okay. And because it's a portion, we find it the same way. We take its central angle here and we put it over 360. So central angle over 360. But instead of multiplying it by circumference, we multiply it by the area because it's a portion of the area, which is pi r squared. So that's your formula for finding area of a sector. So I want you guys to draw this diagram down, pause the video, and try it on your own first. This is degrees, by the way. So go ahead and pause the video and try it on your own. All right, now that you've tried it on your own, let's go through it and make sure you got it right. It wants me to find the area of the shaded region. I notice that the shaded region is a sector, so I know my formula is going to be central angle over 360 times my pi r squared. Okay, so my central angle right here is 70 degrees because its vertex is on center, so 70, times my pi r squared. My radius they give me is 5. Remember, radius goes from the center to the edge of the circle. And remember, we are not typing in pi, and we're also not going to put a decimal at all in this answer. Previously, in our other lessons, we could put decimals down because there were no pi in the formula. Okay? In this formula, there's pi, so I need to do improper fractions. No decimals as answers. So I'm going to put this in my calculator times this. So when I grab my calculator, let's make this a little bigger. I'm going to do my n over d button. If I use n over d, it won't give me a fraction, or it won't give me a decimal. And I'm going to arrow to the right, and I need to times it by 5 squared or 25, whichever way you want to write it. And it gives me 175 over 36. So in my answer over here, I'm putting 175 pi over 36, and my units is centimeters squared. This squared because it's still area, so make sure you still square your units. Okay. Right, so the next problem, again, why don't you draw the diagram, pause the video, try it on your own. This time I want the other shaded part, so go ahead and pause the video. All right, now that you've done it on your own, they want me to find the area of the shaded region. That is still a sector, okay? It's still a portion of the area of the circle. It's not the whole circle's area. So it's still a sector, so I'm still doing central angle over 360 times pi r squared. All right, so I need to know my central angle. My central angle is this part of the circle's angle, okay? I need the angle measure around here. Okay, if this is 70, and I know a whole circle is 360, to find this angle here, I can take 360 minus 70, and I get 290. And so now that is my central angle, 290. You need to make sure that your central angle matches, it opens up to the sector that you're trying to find. So I'm not using 70 because I'm not trying to find this sector here. I'm trying to find this one. All right, times pi r squared, and again, my radius here is 12 millimeters. And I just put this and this in the calculator. When I multiply those together, I do get 116. And I gotta leave pi in my answer, and I need my units squared. All right, the next problem is a challenge problem. We can do this problem together, but you might want to pause the video to draw down the diagram. So why don't you pause the video, and when you're ready, restart it, and we'll do it together. All right, so now that you got the diagram drawn, we're going to do this problem. It wants me to find the area of the shaded regions. All right, so we're no longer working with sectors. There's no sectors in my problem. I just have circles within circles within circles. And they're concentric because they share a center. So keep that in mind. Let's see. Let's start with the outer. So we're going to find this first. We're going to find the area of this ring first. Okay, if I notice that ring, let's get my highlighter. That ring is this big circle. It's all the circle. Okay, it's all that circle minus this part right here, all of the insides. Okay, so that ring, that red ring that I want to find, is the big yellow circle, but taking away the green circle. So what I'm going to do is I'm going to take the area of the, let's say, the big circle, and I'm going to subtract away the area of the green circle to find the outer ring. Okay, so remember area is pi r squared in a circle. So for the big circle, I'm going to have pi in the radius. Now, right here, it said from here to here is 2, and then they're all equal with each other. They all have tick marks. Okay, so each piece here is 2. So the radius of the big circle is 8. And I'm going to square it, and then subtract pi times the radius of the green circle. So the green circle goes from here to here, so it's only 3 2s, so that's going to be 6. Okay. Now, just like radicals, just like variables, when I have this, when I simplify this down, so I square 8, I get 64 pi minus square 6, I get 36 pi. Okay, the pi acts just like a variable. Okay, so if I had 64x minus 36x, I would write down 12x, right? So it's the same thing here, it's just instead of an x, it's a pi. All right, I subtract coefficients and I leave the variable or the pi, the symbol. Oh, 28 pi, not 12. I'm crazy. 28 pi. That would be 26. All right, so the pi acts just like a variable. All right, now the only other ring I need to find is this blue ring right here. All right, I gotta find all of that. All right, so that blue ring, let's see how this will work. That blue ring is going to be, oh, that makes it black. Let's not do that. Let's try green. It'll just be green. Yeah. All right, that's not gonna work. I thought I was gonna be smart, but I wasn't. All right, that blue ring that I want to find right here is in the red circle. Okay, it's in the red circle, but I have to take away this little circle inside, the blue one. Okay, so just like before, it's the same thing. I'm just focusing on the 2 inner circles. So I'm going to take the area of the red circle and subtract the area of the smallest circle. Okay, so the area of the red circle is going to be pi in its radius. So the red is just 2 2's, so that's going to be 4. And then pi times the radius of the small circle, which is just 2 squared. So I get 16 pi minus 4 pi, and when I subtract those, I get 12 pi. And it wants the area of the shaded regions. The two regions are the rings, so I have to take these two and add them together. So the area of shaded is taking the 28 pi plus the 12 pi, and I get 40 pi, and it's going to be units squared because I don't have any units. Okay, so whenever you have to do shaded regions like that, you're just taking the larger area and subtracting the smaller area, or subtracting the area of the shape that's not shaded, and it'll give you the area of what's left over. All right, so let's try another problem. I'm going to have you guys draw the diagram down and pause the video and try it on your own first. So go ahead and pause the video. All right, so now that you've tried it on your own, it asks for the perimeter of the following sector. So perimeter of the following sector is the length all the way around here and the radii, okay? The length from here to here, if we remember from our last unit, is arc length. So I'm actually taking the arc length and I'm adding both radii to it to get the perimeter of the sector. All right, so remember arc length was the central angle, so I need to find this angle here. So I'm going to take 360 minus the 110, and I get 250, times the circumference, which is 2 pi times the radius, and our radius is 4. And again, remember you're just multiplying this, the 2 and the 4 together, so when I do that, I get 50 over 9 pi. Yes, we still need to keep it as a fraction, and we still got to leave pi. Okay. And then, to find the perimeter of the sector, we take the arc length, which is 50 pi over 9, and we add it to both radii. If I simplify that down, plus 8. That's as far as I can simplify that down. Okay, I can't combine them because 8 doesn't have a pi, so they're not like terms. So you have to leave it like that. And that is the most exact form of this answer. And I have to do that because I have pi in the answer. All right, next problem. I want you guys to draw the diagram down, and I want you to try the problem on your own. So go ahead and pause the video and try it on your own. All right, so now that you've tried it on your own, let's do it together. I want the area of the shaded region. So the shaded region's in green. I notice that it's actually inside of a sector right here. Okay, and if I'm finding area, it's going to be the area of the sector minus this white piece right here. Okay, then I'm doing in blue. All right, so I actually define the area of the shaded, the green. I have to take the area of the sector and minus the area of the blue. Now the blue is a triangle, so I'm going to subtract the area of a triangle. All right, so let's find those pieces first. Area of a sector is central angle over 360, so my central angle I actually don't have. But if I notice this triangle that I have, all the sides are equal, which makes it equal lateral. Therefore, it's equal angular, And if all the angles in a triangle have to add up to 180, divide that by 3 and I get 60 degrees. So my central angle is 60 degrees. Times pi r squared, my radius is 6. Okay, put that in the calculator, simplify it down, I get 6 pi. So the area of the sector is 6 pi. Then I need to find the area of the triangle. Alright, so remember that's 1/2 base times height. My base is 6. But I don't have my height, so I need to find my height. So I'm going to draw in the altitude. So I draw in this altitude. I have now created a right triangle, and that has become 30. So I have a 30, 60, 90. Okay? Remember, when you draw in the altitude, it's also the median, so it cuts this bottom piece in half. So this is actually 3. So I'm going to redraw that. I have a right triangle where the base is 3, this is 60 degrees, and this is 30. Okay, this is the short side. I need the height over here, which is the long. So I'm going to short the long, so I just multiply by square root 3. So 3 square root 3 is the height. And again, I'm going to leave it as simplified radical, so I have to multiply the outside numbers together, and I get 9, and it has a square root 3. Alright, so now that I have my two pieces, to find the area of the shaded, I have to take the area of the sector, which is 6 pi, and subtract it from the area of the triangle, which is 9 square root 3, and that's going to be inches squared. Alright, because I pi my answer, that's going to be how I write it. That's the exact form. Okay, you gotta get used to saying stuff like that, because next year you're going to be writing your answers in that kind of form.